Question 21. What causes overvoltage or undervoltage in a power transmission network, and how is the system protected against these conditions? Undervoltage in a power system usually occurs when the load current increases significantly. As the demand for electrical power rises, voltage drops can appear throughout the network. Overvoltage can occur due to several factors, including resonance within the power system, sudden disconnection of large electrical loads, excessively high transformer tap settings, and other abnormal operating conditions that cause the system voltage to rise above its normal value. Both overvoltage and undervoltage conditions can be harmful to electrical equipment. They can reduce system reliability and may damage insulation systems, motors, transformers, and other power system components. To protect the network, protective relays are used to detect abnormal voltage levels and isolate the affected section of the system. The most common protection devices are overvoltage relays, which operate when the voltage rises above a predetermined limit, and undervoltage relays, which operate when the voltage falls below a predetermined limit. These protective relays help maintain system stability and protect equipment from damage caused by abnormal voltage conditions.
Question 22. How does a resonance condition occur in an electrical circuit? A resonance condition occurs when the inductive reactance and the capacitive reactance in a circuit become equal. In other words, resonance takes place when XL equals XC, where XL is the inductive reactance, XC is the capacitive reactance. At this point, the effects of the inductor and capacitor cancel each other out, creating a resonant condition in the circuit. Resonance can lead to unusually high voltages or currents, depending on the circuit configuration, and may cause stress on electrical equipment if not properly controlled. For this reason, resonance is an important consideration in the design and operation of power systems, transmission networks, and electrical installations. Question 23. What is meant by the nominal voltage of a three-phase system? The nominal voltage of a device or electrical system is the normal operating voltage for which the equipment is designed and rated. In a three-phase power system, the nominal voltage is expressed as the line-to-line voltage, also known as the phase-to-phase voltage. For example, when a system is referred to as a 400 kV, 132 kV, or 20 kV system, these values represent the normal line-to-line operating voltage of the three-phase network. The nominal voltage serves as the reference value for system design, equipment ratings, installation coordination, and safe operation of the electrical power system. Question 24. What factors cause frequency variations in a power system? Frequency variations can occur due to several factors within the power network. These include the loss of part of the generation capacity, the sudden disconnection of a significant amount of electrical load, or the occurrence of a severe and long-lasting short circuit. When generation and consumption are no longer balanced, the system frequency begins to change. Maintaining this balance is essential for the stable and reliable operation of the electrical grid. Severe disturbances, such as major faults or large generation outages, can cause noticeable deviations from the nominal frequency and may require corrective actions by the power system operators.
Question 25. What is the normal frequency variation range in a substation? The acceptable operating range of frequency variation is plus or minus 0.3 Hz around the nominal frequency of 50 Hz. In other words, a frequency between 49.7 Hz and 50.3 Hz is considered acceptable for normal system operation. The National Dispatching Control Center is responsible for maintaining and stabilizing the frequency of the power network within this allowable range. Keeping the frequency stable is essential for the safe, reliable, and efficient operation of the electrical grid and all connected equipment. Question 26. What are double-circuit cables and transmission lines? Double-circuit cables or transmission lines are defined as a pair of cables or overhead lines that share a single circuit breaker at the supplying substation. In other words, when two cables or two overhead lines are connected in such a way that they are jointly controlled and protected by the same circuit breaker, they are referred to as double-circuit cables or double-circuit lines. This arrangement is commonly used in power systems to improve reliability, increase power transfer capability, and provide greater operational flexibility. Question 27. What is meant by a hot line? A hot line is a power line that is energized and operating under voltage. In other words, any electrical line that has voltage present on it is considered a hot line. Because it is energized, direct contact with the line can be extremely dangerous and may result in electric shock, serious injury, or death. Therefore, special safety procedures and protective equipment must always be used when working near a hot line. Question 28. What is a low-voltage device? A low-voltage device is any electrical device, equipment, or conductor that is normally used in a power system at a voltage level of 400 volts or less. In other words, if the operating voltage of a device does not exceed 400 volts, it is classified as low-voltage equipment. Examples include residential electrical installations, lighting circuits, small motors, distribution panels, and many industrial control systems operating within the low-voltage range. Question 29. What is a high-voltage device? A high-voltage device is any electrical device, equipment, or conductor that is normally operated in a power system at a voltage level greater than 400 volts. In other words, whenever the normal operating voltage exceeds 400 volts, the equipment is classified as high-voltage equipment. Examples include power transformers, transmission lines, substations, switchgear, circuit breakers, and other components used in power generation, transmission, and distribution systems. Because of the higher voltage levels involved, special safety procedures and protective measures are required when working with high-voltage equipment. Question 30. What are the transmission, subtransmission, and distribution voltage levels used in Europe, many parts of the world, and the United States? In Europe and many parts of the world, distribution voltage levels commonly include 6.3, 11, 20, and 33 kV. Subtransmission voltage levels commonly include 63 and 132 kV, while transmission voltage levels commonly include 230 and 400 kV. In the United States, distribution voltage levels commonly include 4.16, 12.47, 13.8, 24.9, and 34.5 kV. Subtransmission, or subtransmission network, voltage levels commonly include 69, 115, and 138 kV, while transmission voltage levels commonly include 230, 345, 500, and 765 kV. Question 32. What is the main function of high-voltage substations in a power system? The main functions of high-voltage substations in a power system are: first, to provide network control and maneuverability through switching operations. Circuit breakers and switching devices allow power flow to be redirected, transmission lines to be connected or disconnected, and network configurations to be changed safely. Second, to increase voltage at generating stations by using step-up transformers. Raising the voltage from levels such as 20 kV to 132, 230, or 400 kV reduces current and minimizes transmission losses over long distances. Third, to reduce voltage near consumption centers using step-down transformers. The voltage is gradually reduced from transmission levels, such as 400 kV, to lower distribution levels, such as 63 kV, 20 kV, and finally 400 volts, making the electrical energy safe and suitable for industrial, commercial, and residential consumers. In summary, the main function of high-voltage substations is to enable switching operations, increase voltage for efficient transmission, and reduce voltage for safe and practical consumption. Question 33. What are the types of high-voltage substations, and where is a 63 kV to 20 kV substation used? High-voltage substations are generally classified into three main categories. The first category is generation substations. These substations are located near power plants and use step-up transformers to increase the generator voltage to transmission levels, such as 132, 230, or 400 kV, for efficient long-distance power transmission. The second category is distribution substations. These substations are located near load centers and are responsible for reducing transmission voltage to lower distribution levels suitable for industrial, commercial, and residential consumers. A 63 kV to 20 kV distribution substation belongs to this category and is typically used to supply cities, industrial areas, and other major load centers. The third category is switching or coupling substations. These substations are installed within the transmission network and are mainly used for network interconnection, switching operations, power routing, and improving system reliability. They usually do not perform significant voltage transformation. In summary, high-voltage substations are classified as generation substations, distribution substations, and switching substations. A 63 kV to 20 kV distribution substation is typically used in the distribution network to feed load centers and deliver electrical energy to consumers. Question 34. What is a power plant substation? A power plant substation is a substation located directly next to a power generation facility. Its primary function is to receive electrical energy from the generators and increase the voltage to a level suitable for long-distance transmission. Electricity is typically generated at relatively low voltages, such as 11 kV or 20 kV. A step-up transformer then raises this voltage to transmission levels, such as 132 kV, 230 kV, or 400 kV. Increasing the voltage reduces current and minimizes power losses during transmission. In addition to supplying the transmission network, a power plant substation also provides electrical power for the plant's internal loads. These loads may include auxiliary equipment, cooling systems, control systems, pumps, fans, and other essential plant services. To ensure safe and reliable operation, the substation is equipped with circuit breakers, protection relays, transformer protection systems, and other switching and protection devices. In summary, a power plant substation is located adjacent to the generating unit and performs two main functions: increasing voltage for efficient power transmission and supplying electrical energy to the internal systems of the power plant. Question 35. When are GIS substations used? GIS, or gas-insulated substation, is a type of high-voltage substation in which the main electrical equipment is enclosed within sealed metal compartments filled with SF6 insulating gas. In a GIS substation, equipment such as circuit breakers, disconnectors, busbars, current transformers, and voltage transformers are installed inside gas-insulated enclosures rather than being exposed to open air. GIS substations are typically used in areas where available space is limited, such as large cities, densely populated urban regions, underground facilities, and industrial complexes. Their compact design allows them to occupy only a small fraction of the space required by conventional air-insulated substations. They are also widely used in environments with severe pollution, high humidity, dust, salt contamination, or harsh weather conditions. Because the equipment is enclosed within sealed compartments, it is protected from external environmental effects and operates with high reliability. The main advantages of GIS substations include a very small footprint, excellent insulation performance, high operational reliability, improved safety, and reduced sensitivity to environmental conditions. In summary, GIS substations are used where space is restricted or environmental conditions are unfavorable. Their equipment is enclosed within metal compartments insulated by SF6 gas, providing compact size, high reliability, and superior insulation performance. Question 36. What is a bay in a substation? A bay in an electrical substation is a modular section that contains the equipment required for switching, protection, control, and measurement of a specific circuit. Each bay is designed to operate as an independent functional unit within the substation. Depending on its purpose, a bay may be connected to a transmission line, a transformer, a feeder, or other electrical equipment. A typical bay includes a circuit breaker, disconnectors, current transformers, protection relays, measuring devices, and a connection to the busbar. Substations are usually composed of multiple bays. Examples include feeder bays, transformer bays, and line bays. Each bay performs a specific function while remaining connected to the overall substation system. One of the main advantages of the bay concept is operational flexibility. If a fault occurs within one bay, that bay can be isolated without interrupting the operation of the remaining bays. This improves system reliability and simplifies maintenance activities. In summary, a bay is an independent and modular section of a substation that contains switching, protection, measurement, and control equipment associated with a particular circuit or piece of electrical equipment. Question 37. What is a substation layout, and what factors determine it? A substation layout is the engineering arrangement and physical positioning of all equipment within a substation. It defines where transformers, busbars, circuit breakers, disconnectors, transmission line terminals, protection equipment, and other components are installed. The layout is typically represented using two engineering views. The first is the plan view, which shows the arrangement of equipment from above. The second is the elevation view, which shows the heights and vertical positions of equipment. Several factors determine the layout of a substation. One important factor is the geographical location of the site. Terrain conditions such as mountains, urban areas, deserts, or flat land can significantly influence the arrangement of equipment. Another factor is the voltage level of the substation. Higher voltage levels require larger electrical clearances and greater spacing between equipment. Safety regulations and insulation clearances are also critical. Adequate distances must be maintained between energized parts, equipment, and personnel access areas to ensure safe operation. The type of substation also affects the layout. Gas-insulated substations require much less space than conventional air-insulated substations. Other important considerations include the expected load demand, operational requirements, maintenance accessibility, future expansion capability, and overall system reliability. A well-designed layout provides safe operation, efficient maintenance, reliable performance, and sufficient space for future development. In summary, a substation layout is the planned arrangement of equipment based on engineering requirements, voltage level, safety standards, geographical conditions, operational needs, and future expansion considerations. Question 38. Why are tubular bus bars used in high-voltage substations? Tubular bus bars are widely used in high-voltage substations because they provide better electrical and mechanical performance than solid conductors. In alternating current systems, most of the current flows near the outer surface of the conductor due to a phenomenon known as the skin effect. As a result, the center portion of a large solid conductor carries very little current. A tubular bus bar takes advantage of this characteristic by removing the unused central material and concentrating the conductor material where the current actually flows, near the outer surface. This design reduces conductor weight while maintaining excellent current carrying capability. It also improves current distribution, reduces electrical losses associated with the skin effect, and increases overall efficiency. Another important advantage is improved heat dissipation. Because the tubular structure has a larger surface area relative to its weight, it can release heat more effectively and operate at lower temperatures. Tubular bus bars also provide high mechanical strength and can withstand electrical and mechanical stresses caused by short circuits, wind loads, and equipment connections. In summary, tubular bus bars are used in high-voltage substations because they reduce the effects of skin effect losses, improve current distribution, provide better cooling, reduce weight, and offer excellent mechanical strength and reliability. Question 39. What are outdoor, indoor, and metal-clad substations? Substations can be classified into three main categories based on their installation environment and insulation method: outdoor substations, indoor substations, and metal-clad substations. An outdoor substation is installed in open air, where equipment such as transformers, bus bars, circuit breakers, disconnectors, and insulators are exposed to environmental conditions. These substations require a relatively large area but are generally less expensive to construct and maintain. They are commonly used in transmission and distribution networks where sufficient land is available. An indoor substation is installed inside a building or enclosed structure. The equipment is protected from weather conditions such as rain, dust, humidity, and pollution. Indoor substations require less space than outdoor substations and are often used in urban areas, commercial buildings, factories, and locations where environmental protection is important. A metal-clad substation uses switchgear and electrical equipment enclosed within grounded metal compartments. The equipment may be insulated by air, insulating oil, or insulating gas such as SF6. Because all live parts are enclosed, metal-clad substations provide a high level of safety, reliability, and protection against accidental contact. They are compact and widely used where space is limited and operational safety is critical. In summary, outdoor substations are open-air installations, indoor substations are housed within buildings, and metal-clad substations use sealed metal enclosures to provide compact design, enhanced safety, and improved reliability. Question 40. What is a feeder in an electrical system? A feeder is an electrical circuit or power line that carries electrical energy between a substation and load centers, or between different parts of a power network. Feeders are used to transfer power from the substation bus bar to consumers such as residential areas, commercial facilities, industrial plants, and distribution transformers. In some cases, feeders may also carry power into a substation from another part of the network. A feeder typically begins at a circuit breaker connected to the substation bus bar and extends toward the area being supplied. Multiple feeders can be connected to the same bus bar, with each feeder serving a different section of the electrical system. The primary function of a feeder is to transport electrical power efficiently and reliably from the source to the load while allowing protection, control, and switching operations to be performed when necessary. If a fault occurs on one feeder, the protection system can isolate that feeder without interrupting service on the remaining feeders connected to the substation. In summary, a feeder is an incoming or outgoing electrical line that transfers power between substations and load centers, forming an essential part of the power distribution network.